All right, so I'm going to do like a soft start here as people are still coming in, and I can fully understand that. 9 o'clock is a very early time, not just for the participants, also for the speakers. But yeah, I know a lot of people went to some events and parties last night. I was also one of them, but I still appreciate you all made it. So yeah, good morning. Welcome to this talk about observability options around the area of Kubernetes and Spring Boot. I wasn't really sure how to place the title for that. So as I said, like from K9s to OpenTelemetry, where I want to define a certain kind of range of options. So it's not only about those two tools in particular. I'll try to talk about many and kind of bring them into relation and into context. Also, I'm not sure if you can see the background of the slide. This is, I had to smile when I saw it this morning because a colleague of mine created that title page for Spring.io last year. So if you can't see it, it's Barcelona, it's the Sagrada Familia and so on. And I thought that's a great idea, and I'm going to keep on doing this and put like a image of the city in front of the title, or at the title wherever I'm going to speak. I totally forgot, and now all my slides have Barcelona in front of them. But it's good. It's kind of carrying that Spring.io spirit into other conferences. Now, okay, let's start. A few short words about myself. My name is Matthias. I work for a company called Novatech. We are also a proud sponsor of this conference, like since last time. You might have seen a few of my other colleagues around, so we're doing some talks and some workshops. In that company, I try to do some kind of cloud-native consulting, if this is a term, where I kind of try to enable clients on their journey towards cloud-native software engineering. This goes a lot with like roadmaps, strategy, but also enablement and hands-on and implementing things. Next to that, I also teach distributed systems at 2 universities in the area of Stuttgart. And many of my talks and ideas actually come out of this lecture. So yeah, distributed systems is a bit of an old, like, gray term. I'll try to do like distributed systems with modern technologies, and Spring Boot and Kubernetes and things like that I consider as modern technologies, and observability and getting insight into those things is of course a part of that. So that's kind of where this originally also came from. I'm sometimes fairly active in social media, so you can connect to me on LinkedIn or Twitter. I also started using this new Mastodon and Blue Sky things, but it's not like the majority of things that I do is probably still on the Bird network. All right. So yeah, in a nutshell, I said it before, this is what it is about. It's not, I labeled this talk observability for Spring Boot apps. We could potentially say it's more about apps in general, Java in particular, and the example I'm going to show today are based on Spring Boot. But it's certainly not limited to all of that. So I started doing this talk, and I just called it What's Going On in My Cluster, because I'm also teaching Kubernetes classes very often, and I found it pretty difficult to understand for people getting started with it to see what's actually going on. So this is kind of the thing that I want to do today, from not knowing anything at all to seeing, okay, this is what happens inside, and I'm getting a kind of a grip of that. All right, so I don't want to do this hand-raising game all the time because I know it's early, but who of you is using Kubernetes? Okay, that's good. Because, yeah, I saw this session from Mauricio Salentino yesterday, and we talked about it. It's like with Kubernetes, it's always difficult because it's difficult to estimate to which level people know it already. And it always comes along with a bit of an introduction. So I'm just going to say a few words about it, but I'll keep that short as I saw so many hands. The interesting thing also when it comes to observability is kind of that split that you have on one side your application, your workloads, and on the other side the infrastructure and the cluster itself. So both of the things you should basically have a bit of an idea of what's going on. As we're going to talk about infrastructure later on a bit more as well, the cluster is basically made of multiple worker nodes. This is as the name implies, where all your workloads running on, and this control plane that coordinates things in the worker nodes. So your application workloads can be of different implementation types. So this is like all Java options here, but they're not limited to Java. So everything that you can basically run in a container is what you can run in Kubernetes. On the other side of the workloads, and this is normally the thing which people have to learn when they start with Kubernetes, is the API objects. And it's like an own language kind of thing. So you have services, deployments, replicas, and so on. And it's kind of the connection of those things you need to understand if all your stuff is going well. Also, I didn't say that in the beginning, but normally I'm not a fan of just like this top-down kind of speaking. So if you have any questions throughout this presentation, please feel free to raise your hand, or if you think I'm saying something which is not right, also let me know. I'm definitely open for feedback. Otherwise, we can, of course, still do this in the end. Now, taking a bit of a closer look of how you can get to those things. There is the so-called API server, which runs on the control plane, and this is where most people are basically interacting with the cluster. So that's where they're querying information or where they're applying commands in order something to get executed or deployed. Yeah, so all in all, this is the things we're going to look at. And of course, we don't only want to know about the individual state of our applications, but also if they are connected and how those connections go, and what is the time in between to isolate problems in case they start to occur. All right. Now, as there are so many things, there are also many kind of access points how you can get into and query information. So of course, there is the application level, where you can query application metrics. Then as things are running in a container, you have the container or the so-called pod level, which is like a container around the container. And we will see later on why this can be useful in terms of observability. We got the nodes where the things are running on. And as I said, we got the API server. So technically speaking, from an observability perspective, you can reach out to all of them. And that's also kind of the thing what makes it a bit tricky. So where do you start and what do you actually want to know? So this is kind of my goal for today, to provide a bit of an overview of the various ways how you can interact with such a system, and also in a way how much you need to invest or change in your code or in your container or in your infrastructure to get all those things out. I mean, this is what I do very often in my, say, consultancy part, because, I mean, with observability you can do many things, but sometimes you can also put things in there that you don't take any benefit out of. So this is about to get a bit of an estimation to say, well, this is what I want to know, and this is how much I want to actually pay for it, and then also to say, are there certain, is there a certain journey or steps how you can move forward if you want to track down something in particular. All right, so there's the API server, nodes, pod, and with this pod, there is this idea of a sidecar pattern, which can be used for observability that I'm going to show in a later part of that demo, or that presentation. All right, good. So this is about the concepts. Now, how are you going to start? What are the options? For those who are already familiar with Kubernetes, you probably know there is a lot around. This is probably an already outdated version of the so-called CNCF landscape, because it's, I think, 2 weeks old. It changes very often, new things getting added, and it's kind of hard to get all your, to navigate through that. There is a certain dedicated section on observability and analysis, and I'm going to show some tools out of that, but also I'm going to show different ones which are not listed in there. So yeah, just a disclaimer right here. If I forget to show some tools, or you think something I should probably mention here as well, please let me know. I mean, of course, it's super hard to cover all of the aspects, all of the tools. The ones I'm going to show is mostly the ones I'm most familiar with, and there's definitely more. So if I focus on one thing more than the other, that doesn't mean it's better in any way. It's just like, this is probably better, like I have more experience with that. All right, so let's start with the highest level, or the first level of interaction, like getting to the Kubernetes API server. So this is probably what you did first when you got started with it, getting the kubectl API, command line interface, and querying that information, like get information, describe a certain object, getting the logs, executing some commands, or doing some debugging. By the way, who has ever used from those people who had raised their hand before, who has used the kubectl debug statement? Okay, there's a few. This is hopefully your first learning for today, because it was like me a couple of months ago, and somebody showed it to me, and I found it quite impressive. So I'm going to show you in a second. Now, there are tools there's kubectl as a command line tool. There are also other tools that use the API server, and basically can get the same result as we would be able to get from kubectl, but just like presenting it to you in a more aggregated and easier to navigate form. So there are CLI tools, web clients, and fat clients. When I started with this presentation, I used the tools Octant from VMware, Lens, and Weaveworks. Now, over time, Octant got officially deprecated. Is there anyone from VMware in the room? No. I wouldn't raise my hand now either. Yeah, it's a bit of a sad thing because I really like that tool. Then Weaveworks did not officially deprecate this scope tool, but it certainly has less activity, as you can tell from GitHub. Lens is still around, but it kind of turned a bit into a commercial version. There's still like a free or an open alternative. But K9s was the one that was around all the time, and it's still a good OSS friend, so I'm definitely going to highlight this in a positive way. And I'm going to have a look at two new tools that I just discovered recently. So one is called Headlamp, the other one is called Schooner, which technically provide similar things as Octant or we've scoped it before. So I'm trying to do things in a demo, but my demos don't always work great, so I have a bit of backup screenshots. This is basically what K9s looks, so it's fully based on the CLI. You don't need to install any kind of fat client code or need a browser, so you can run this from pretty much every shell. That's a big advantage there. That's what Octant looks like. As I said, I'm not going to demo on this, but in the end, as a summary for those tools, and it's also very helpful, especially for beginners, as those Kubernetes objects kind of get aggregated. So you see what is under workloads, what is under discovery and load balancing or networking, and so on. So it's kind of a browser over your objects. This is the one from Lens, and this is the Headlamp and Schooner that I just talked about. So I will show that right in a minute, what you can do with it. Now, going back to that debug thing, as only a few people raised their hands, and as I said, this was fairly new to me as well. This is a way how you can actually attach a container to a running container in a pod. And not in a way like as you would do it with a sidecar pattern. It's actually, they're going to share the same namespace, and not the Kubernetes namespace like the container or the Linux namespace. And so you can load kind of new binaries in your existing container and then execute them without restarting or changing anything. So imagine you have a situation where you have like a distro-less container and you don't have any shell or any commands in there. This one can be certainly very helpful then, because then you can add tools to a running system and start looking into it. So the call to do that is basically say kubectl debug, then point to a pod, and then attach your image that of a container that you want to attach to it, and then it's going to run in that namespace. So as I said, I'm going to show that in a minute. So, what does the time say? That's still good. Okay. I have too many tabs open, I know that. If you start such a tool, so I have command line here. So let's start with K9s before. So I have two clusters, I think, running, because not all the tools that I'm going to show later on are working with each other well. And yeah, so the limitation that you normally have with the Kubernetes command line, so if you, for example, list all the pods and you have quite some things running in there, it's kind of easy to start navigating and getting a good visualization around that. So with K9s, this can be pretty helpful. As I said, you can run this in every kind of command line environment. You can say, okay, I want to see all the namespaces. And here I would also get some kind of a high-level indicator if things are not okay. So I could potentially drill into that, getting the logs out of it, then So yeah, I have the Spring Pet Clinic here, I have the OpenTelemetry demo and some own written things. But anyway, so yeah, what you can do here is, for example, go into it, then, for example, grabbing the logs, going back to the beginning of the logs, and it's just like with a few kind of key combinations, you can navigate around your browser pretty quickly. The other one I wanted to show is the headlamp, for example. So I'm creating a token here real quick. And so this is the same thing that you get in a browser then. This is actually running within the same Kubernetes cluster, so it has access to all the information in there. And as I said, it's fairly easy to navigate with the mouse. So you have a summary of like workloads, storage, network, whatever items. And yeah, it's quick and easy access. So if you go into your pods, you can say, okay, I see how well they're running, or if they're not running. Then if I want to look into a certain one, let's say I'm taking this Redis one here, for example, I also have the options to see all the logs in here. And the other cool thing is you can also open a shell in there. So it tries to execute a shell in that container, and then you can basically have a shell based in your browser and do a quick kind of inspection in that way. So I use that fairly frequently if I want to quickly see kind of what's going on. Now, coming back to that, the distroless thing. So if I ever find it, so of course, yeah, as you can see, this is still, can be still difficult. Oh, so here it is. So this is my distroless application. There's a Spring application running inside. I'm able basically to query the logs, but if I want to open up a terminal, it tries many things and it can't connect. So this one is giving up here. So even if I go to the command line and say, where is it? It's this one here. So I'm just going to switch to that namespace. So if I want to say, okay, kubectl exec, using that, no, sorry. And want to, for example, grab the environment variables or something like that, or do a PS. They're not going to work because it's a distroless image, so nothing is actually in there. Even if I try to do like a shell, this is probably what I'm normally doing, say bin bash, and I exec this with like with the IT flag, so to get a terminal there. Yeah, it says there's no bash in there, and there's no shell in there. So this would actually technically give me a pretty hard time to debug and get around things. So speaking of debug, there's that debug call. So basically, I'm pointing to that pod right now, and say this is like an image that I built myself, where I put various kind of toolings inside. Now suddenly I'm getting a shell in that container because the shell binaries and everything is implemented in that image. So now I can do like a PS3, for example, or a colleague recently asked me if I can't, like, he would like to have an HTOP rather than a top monitoring in his container. So I built that into that image as well. And now I'm in that container and can do all those tools. So this is something what I found really helpful. It's of course a bit dangerous, and I think normally not every administrator should allow that call. But if it's like, if you're in a development and testing environment, this can be certainly helpful. So I have like all the tools like NSLOOKUP and all the network tools inside to also make sure I can see if the connections to other services work and just see if this is all in a healthy state. All right, so that's that for the first part of this demo. The good thing with all those toolings is you don't need to change anything in your cluster or your apps. This is just vanilla Kubernetes API. It's non-intrusive, and it doesn't cause any overhead to you. So it helps for understanding Kubernetes and getting a better overview, but there are limitations. I mean, we saw that in K9s. We see if a certain tool has problems with starting and so on, but it won't be able to like discover any kind of ghost containers. They're running, but they're not working. You also won't be able to see if containers and applications are connected. And that's probably the most important thing in a distributed application landscape. Sorry. Right, so the next one is, I'd call it pod-based monitoring. Some technology that makes quite use of that is the service mesh technology. So who in here has worked with service meshes? Also a few, but not as many hands. So I'm gonna talk about that a bit more then. Say, this is that level where we want to get closer to the application flows in the cluster. So we're basically adding, we're trying to inspect on the level of a pod. Now, when I talk about, when people hear service meshes, observability might not be the #1 thing that comes to their mind. It's normally more like mutual TLS encryption of services or customized routing, rate limiting, circuit breaking, all those things. But there's this technology called Cilium. They try to build a new service mesh that I'm going to talk later on as well. They made a survey of what are the features and functions that people would expect of a service mesh. And by a big surprise, actually, observability was the #1 thing. So there is a certain need, or that people basically use service meshes for getting insights into their stuff. So a quick, for those who didn't raise their hand yet, the way that works, as I said, applications are running in containers, and in Kubernetes they're running in a pod. This is like kind of the smallest deployment unit that Kubernetes knows. And with that, it's going to be connected to the Kubernetes network traffic, and things can basically interact. With this sidecar technology, or with this basically pod technology in general, you can also place multiple containers in a pod. From an application standpoint, I would never recommend you to do that, because you won't be able to scale the things individually then, and if like pod can either go up and go down, so you basically take out a lot of advantages. However, for one thing that it's good for is when you place multiple things in a pod, they share the same IP address or the same port range. So basically they can connect with each other blindly without any further changes needed. So where this can become very helpful if you place your observability agent, so to say, right into a pod. Because this kind of sidecar or proxy, or whatever you want to call it, will then see all the traffic that the application sees as well. And this doesn't make a whole lot of sense if you do it only in one pod, but if you place it in all of them, you basically have insights over the entire network flow in your cluster. So people normally speak about it. Oh, I'm not in presentation mode, I'm sorry. Just noticed that. So for the people in the back, I hope you can see it better that way now. So you have the data plane where you collect the things, and the control plane where you put them together. And the good thing here as well is this is totally independent of your application runtime or programming language. As it's not actually touching the application, you don't need to rebuild the application or anything alike. You just need to inject that proxy. And that also means you can easily swap it in and out again. So playing around with it and seeing if it does a job for you is an easy thing here without affecting anything else in your development workflow. Yeah, and the good thing is you're not only able to control all the network traffic then, but you get insights to it. I mean, with an application of that magnitude, you would probably not need it. But just to give you an idea, here you can see now, are my connections encrypted? What is the traffic distribution? You can also see like latency times and throughput and so on. So this can be very helpful for you to say, I want to do observability on not only detection, but isolation level. I want to see who are the poor performing services. And if I have isolated them, then I can do a deeper drill down into those. This is one application that probably some of you will be familiar with. It's the Spring Cloud, the Spring Pet Clinic. And yeah, this is just basically what you get without any further configuration. You just basically put the sidecars in, and then you see all the flows in there. Yeah, if this is also great, why does not everybody do it? By the nature of things, you get more overhead when you apply that. I mean, technically speaking, you're adding a new container to every instance of your application containers. So there's an increase in CPU and memory, of course. But what is even kind of worse is the latency that you add. Because if an application was talking to another application before, now this application will talk to a proxy, the proxy talks to another proxy, and then the proxy talks to the application again. This certainly has an effect. this is the statistics from the CNCF about the two most common technologies, which are Istio and Linkerd. And I wouldn't get too hung up on what level on percentiles you would see what kind of latency. This is always different from one application to another, but it's still, yeah, you will see it. So my recommendation is try it out and play around with it, and then you see if this is something you want to move forward with or not. So I can also show that quickly. And so I have this cluster right here. This is the so-called Kiali console, which is basically sitting on top of Istio and like getting all the metrics in there. So yeah, I have two active namespaces here. I have one active namespace now. This is the OpenTelemetry demo. So if I go into that graph view, it will basically show me all the flows in that environment. So this one is a little bit bigger, so I got to zoom in. And then I can say, okay, what do I want it to do? I mean, the most important thing is, of course, to enable the traffic animation, because then you will actually see, hopefully see, so, oh yeah, no, it's here. So this is the real value of this. No, I'm just kidding, but it's nice. But what you still be able to see is, for example, let's say the response times. So you get an average of the response times or the throughput. It should actually, why am I not seeing this? Normally, okay, here, now it's suddenly there. I'm not sure why it wasn't there before. Yeah, it's just started the demo. Maybe it hasn't collected all the metrics yet. But you see, like, if there's a certain point that distributes traffic, you can see the percentage of the distribution. You don't see the response time in here yet. I don't know why. Maybe if you look at a demo later on, this is this will be there. But you get an idea of what I'm trying to tell you. So this is something that you can certainly use to say, in the first place, are all my things talking to each other in the way I actually wanted them to talk? And also, who is getting a lot of load, who is getting less load? Do you need to change something in your traffic distribution there? Or also to figure out, yeah, do I have components which return a lot of like bad return codes? What are those return codes? And then continue on your kind of error analysis. All right, so jumping back in here. Yeah, this one would extend Kubernetes for the limitations in the traffic awareness and also shaping, but this is not so much the part of the talk today. It has that concept of injecting an agent. So with the Kube API, you didn't need an agent. You need kind of an agent, which of course would have a drawback for generating a bit of an overhead. But the limitation here also is you don't have any application level metrics yet. So we have covered two parts where we say, okay, we can detect some things, we can isolate things, but we still don't see application level metrics. Now, this one I also want to introduce briefly. I still have a bit to go. That's good. This is who has been using or has heard of the eBPF technology? Okay, yeah, this is still fairly new. It's been around. It's been around for a while, but it became fairly popular over the last 1.5 or 1 year. So it stands for Extended Berkeley Packet Filter, which doesn't really sound like observability, and no matter how often you read it. This is actually a very low-level Linux technology. So, and this means we're kind of leaving that scope right here now, and we're going down onto the nodes and see how we can query information from the nodes. So I'm not a low-level Linux person. I know there's a kernel space and there's a user space, and the kernel space is something which is very protected. This is where things shouldn't go wrong, and this is where it's also kind of difficult to get changes in there. I mean, Linux is of course open source, so you can like create a change and a pull request, but it might take a bit until this is finally make it into the kernel. So this is kind of where eBPF comes in. They have created a certain mechanism to like establish a sandbox behavior in the kernel space. So somebody explained it to me that this is like running JavaScript within an HTML page. It can do all this additional functionality, but it can't break out and do any damage there. And this is supposed to behave in the same way. So that means now you can inject custom codes into the kernel without like rebuilding the kernel and doing all those things. And then you can start listening on kernel events, and network events are of course also kernel events. So you can query it there and then forward it to some kind of applications in the user space. Why is this so important for us? It's because most Linux, most Kubernetes worker nodes are also based on the Linux operating system. So that means you can apply this technology in that context there as well. And if we look at the Kubernetes overall picture, that means you can now place your agents as opposed to a pod on the nodes of your application. So it's in a similar way that this is like the data plane where you query that stuff and then send it to a control plane for visualizing or do any other things with it. Of course, these things need a certain privilege to be run there, but then you have way less latency as opposed to a pod-based kind of implementation, because normally, and I would hope everybody in here can say, I have more pods than nodes. If it's the other way around, we should probably talk after this talk a little bit. Yeah, so this is the idea. I mean, yeah, the visualization is not really good here because I'm missing all the monitored pods, but this is just like the monitoring architecture. All right, so this again would then be the visualization of the Spring Pet Clinic. And again, what is quite nice, that it's just like being picked up without the need to change anything on your pod level. So this is, as I mentioned before, this so-called Cilium technology, and I can show this to you live here in a bit as well. And this is also why I have two clusters. So I have one where I have Istio installed, and I have one where Cilium installed. Technically speaking, you could combine it, but this gave me a bit of almost a heart attack in front, like 10 minutes before starting a demo once, so I decided to separate them now. So this was a wrong click here. So this is that so-called Hubble UI, which sits on top of Cilium in a similar way as Kiali sits on top of Istio. Hey. And then you can see all the namespaces in your environment. So again, for example, let's have a look at the Spring Pet Clinic. And as you can also see, I'm not invoking anything at the moment. So there's no traffic from the API gateway to the various services. If I go back to the overview, and for example go on the OpenTelemetry service, then I can see what the current interactions are there. So things coming in from the world. There's the load generator inside, and that sends the traffic towards the various components. Again, this is only one way to get the things in there. You can also connect to that application and export all the information into Grafana. But yeah, it certainly helps understanding what your components are currently doing, and if the connections between the various components are behaving in the right way. All right, so finally, we come to the last part. And I'm going to switch again. So now we saw various technology to either like high-level detect if things are not okay, or narrow down the scope by isolating components. And now finally we're going to the point to say, okay, now I want to look into the applications. That of course means we somehow have to do something with the application. So either like adding dependencies, adding agents, or adding something to the JVM, as we talk in Spring Boot here. And in the end, from that agent, we would query something, put it into a database, and visualize it in a certain way. And again, here you will have many options. So I've listed a few different tech stacks that I've been working in the past before. And so you can see there is not only one solution. There are different ones, there are different approaches to get there. But one technology I would want to highlight a little bit today is OpenTelemetry, just because it kind of tries to address exactly that thing. I mean, if you go into, I'm only showing open source things here mostly, but of course there are also quite a few commercial solutions out there. And this is always kind of the problem, because of course everybody wants to go down to the deep level metrics and find out the root cause of your things, but those various solutions are not very well compatible with each other. So you either go with one vendor or the other one, and then the danger of a certain kind of login is pretty high. We at Novatech, we normally do like vendor unbiased consulting, so we try to find the best thing for whatever the situation requires. And that's really the reason why I like OpenTelemetry so much, because they try to establish a same level of how metrics being collected and the kind of the way they're being implemented. So there's various sources. You can query and check something in your application code or in Kubernetes or in your infrastructure provider, and they will basically all come together on this OpenTelemetry collector level. And from there, they can be exported to different kind of applications. And they can, of course, be commercial or non-commercial. So the differentiation between the providers will then more like be how are they actually able to visualize and work on the data, rather than giving a hard time to the users to decide what kind of agents should we place here. Yeah, so how does this work? Again, to implement that, there are a couple of options. Again, so up to now, we didn't have to change anything on the application or the container. So with OpenTelemetry, you can start on a level of a container where you don't actually have to change your application, so no recompile and rebuild is necessary. With that, the Docker file I'm trying to describe here is basically you adding, or you kind of the downloading and adding this Java agent for OpenTelemetry, and then you just change the way your JVM is invoked and adding this agent into that call. Yeah, so it's a modification of the container. It will require to rebuild the container, but it will not be required to rebuild the application. In the end, of course, you need to give a bit of a specification to say, okay, where, for example, is my OpenTelemetry collector running? What is the name of that service? So it can be visualized like that in the end. Another ways to do that is actually do modifications in the code. And for Spring Boot or Java, there's also a couple of options here. So you can, for example, use that Spring Cloud sleuth component with the OTel configuration, and then use the sleuth technology on a querying side and export the things into an OTLP format. Again, here you need to configure it and say, okay, these are like the sleuth configuration parts. Here I have my collector, and this is the ID of the application that I'm going to propagate, which will be later on used for visualizing things. Yeah, this is, as I'm not only doing Spring Boot, you have similar things for Quarkus, for Micronaut, for other frameworks. It works in a similar way. You add a dependency, add the configuration, and then you're good to go. Okay, so what's the difference here to what we have seen before? This is a screenshot of Jaeger, which is like a visualization tool for tracing. And the traces that you see here are the ones that were actually collected by a service mesh. So in this case, you only can see basically the outer services, but not actually what is happening inside. And here you have the same thing with an OpenTelemetry configuration, where you then have the possibility to really drill down into the various aspects. So now you can see, okay, I still have the outer rim, so to say, but now you also have like, okay, how long is my database call taking, or which method is spending how much time? So this is basically really when you want to drill down and see what is the problem in your application. If this is not enough, you can also kind of add custom code into your application. So this is kind of the deepest form of intrusion, to say, okay, the auto implementation does not give me all the metrics yet that I want to. I, for example, have found that this fetch product details method or function seems to cause some problems. So now I annotate this with a span name, which is called product handler fetch, and I also use this span attribute. So this is something that OpenTelemetry would not collect out of the box. So with this, you're not only getting the traces, but you're also getting the certain attribute of a certain call when it is invoked. So to say, okay, does a certain kind of customization or attributes make my calls better or worse? And you can always grab them and visualize them. So this is what it would come out in the end. You see like a drill down over, or like a trace drill down over those things. And here you have this product handler fetch. And if you expand it, then you would also see that custom metric that you put in there by yourself as a custom kind of metric. So just a quick thanks to two people. This is, I don't know if you know them. Most people would probably know Beldung if you're in the Spring environment. Nicholas is also a friend of mine. They have quite a few, I mean, especially Beldung has a lot of demos, but also Nicholas had built an OpenTelemetry tracing example where I just took the screenshots from. So I thought this is a good point to give them a quick shout out. All right, I'm almost coming to an end. So I hope this is okay. This timed out. So with Cilium and Istio that I shown before, you're certainly fairly dependent on running the things on Kubernetes. So they have been built for inspecting things in Kubernetes. With OpenTelemetry, it's actually not necessary to use Kubernetes. So this is, as I said, application-based. So it will query the things if they run in a cluster or in a container, but also they will do it without. And so that also means that for the demos or playing around with it, you don't technically need a cluster to do so. I hope this is going to start in a second now. Yeah, I don't have this locally, so I'm using a Git pod here to run this in a browser, if it ever runs. I can still go back. Let's see, how much do I have? So yeah, you've seen there are many tools around here that you could use. And we also have, this is actually something that people from my company at Novatech have built. This is called, I can show this in the browser now too, OpenAPM. And with this one, you have a list of all the solutions of commercial and non-commercial libraries, agents, collectors, and so on. And you can kind of pull them together here in such a landscape. This is also the ones I used for creating that images before. So check this out if you like. This can help you to say what kind of combinations of toolings is actually supported and working well. Now I'm finally here in this application. So here you can see that I have this with span annotations on the various functions. Here I have this span attribute of the ID that I showed in the slides already. So I'm just gonna start and this is what I meant. I'm running the things as a Docker Compose script now. So I have the various application components and Jaeger. So if I open it up in the browser, I have here my Jaeger environment. So that's and I think right now we actually shouldn't be able to see anything. Yeah, there's nothing in there yet. So I'm going to open up a terminal, and I hope I remember this correct. As I said, it's not my code. Yeah, so this worked. Basically, we put something into the system now, and if we go back, we should be able to get some, yeah, so we see things here now, and if I find the traces in that one, I can now see I have this drill down over all the components, so I can see here I have all the standard methods, and here is the one that I explicitly annotated, so I have that product handler fetch, where I then see this is the ID of which has been invoked when I did that call. And in contrast to that, I can, for example, see if I look at a Jaeger environment which is based on Istio, for example, and I check my traces here. I didn't want to take that one. So I don't get all those details in the spans because I'm just collecting basically in the information, when does it enter a service and when does it leave it again. So yeah, many Jaegers around here, but that's basically how you bring it all together. And I think with that, I'm mostly at the end of my presentation. So yeah, in this case, of course, as a big difference to the service meshes, the agents are specific to a programming language. So if the programming language doesn't provide an agent for that, or if nobody has written an agent for that, it's impossible for you to work with it. Luckily, on the Spring Boot side, there's quite a bit that you can use. So one that I did not have in this presentation, unfortunately, today, but I'm going to add it soon, is micrometer, that you can also, of course, use and then export the metrics to OpenTelemetry, or use it as a standalone tooling, of course. And with this one, you can get down as deep as you want in your code. But of course, that means you have to do changes and know your code and know what you're doing there. All right. So with that, we've seen all the various aspects or like paths, how you can get into your cluster and into various levels or like altitude, so to say, of your overall infrastructure. And I would like to say thanks for listening and open it for questions. There's, I see one question there.
Thank you. So OpenTelemetry, you showed this for application telemetry. I think that since OpenTelemetry wants also to allow us to follow everything on all the stack, like there is OpenTelemetry for front end. So cannot we also plug in the service mesh stuff into OpenTelemetry and have, for example, if there is something like that you were showing us in Linkerd or something, have these parts of the traces, and so that it's all in open, that you can just use OpenTelemetry for everything?
Yeah, I mean, I think for OpenTelemetry, you have agents for plain Kubernetes metrics in general. I'm not particularly sure if you can export from the service meshes, but you can certainly export it to the same destination. Like I use Jaeger here now. I had different ones installed, but you could use the same one. It's just like I split them out for various demo purposes. But yeah, and another thing which I didn't mention is when we talk about service meshes in that Cilium technology, they also, what is currently on the roadmap of trying is using eBPF to like custom inject that OpenTelemetry collectors without changing the application while it's running. So yeah, there's definitely a lot of movement in that space at the moment, and I'm pretty sure I didn't cover all the aspects that it can do now. For this one, I really had to validate because I haven't used it in that way. But I totally agree with you. You should not have like 20 solutions in parallel, but make sure to combine it in a way that you get what you want to have. Thanks. Anything else? All right, so maybe a late advertisement. They're also running a workshop today at 2:30 about various options to build containers. We still have a few seats available, I think, because we're actually competing with Josh Long, which is not a very nice thing. Yeah, feel free to drop by, but I'm going to still be around. If you have any more questions, just talk to me. And if you don't see each other here, this is also ways to find me. Thanks again.